physics combines what you need to know about quarks, quark compositions, interactions, and also conservation laws. So let's have a look. So it tells you a K minus meson has a strangeness of -1, and what's the quark composition of a meson in general. So just a reminder, baryons are made of 3 quarks, and a meson is made up of 1 quark and 1 antiquark. So you can write something like quark, and then an antiquark is represented by a line on top of the Q. Now it's asking for the baryon number of a K minus meson. Well, just a reminder, all particles are split up into hadrons and leptons. Just make a little note that all particles are split up into these two. Leptons, they don't split up anymore because they're what we call fundamental particles, so they don't really decay further. Whereas hadrons can be split up into baryons and mesons. So from handwriting. Examples of baryons are protons and neutrons. Examples of mesons are K minus meson, like mentioned here, or the pi meson. Examples of leptons are electrons and neutrinos, etc. Now, mesons in general, because they're not baryons, they don't have a baryon number at all. They have a baryon number of 0. Only baryons have a baryon number of 1. And antibaryons, like an antiproton, would have a baryon number of -1. So what's the quark composition of a K minus meson? If we look at the quark table, there's 2 things we need to know about this meson. Well, 4 things actually. First of all, what's the normal composition, which we know is a quark and an antiquark pair. That's step number 1. Step number 2, we need to know the charge. Well, because it's negatively charged, it has a charge of -1. Step number 3, we need to know the baryon number, which we now know is 0. Step number 4, we need to know the strangeness. If there is a strangeness, it'll tell you in the question. If it doesn't tell you in the question, we always assume it's 0. Here it's -1. Now, if an up quark has a charge of 2/3 e and 1/3, then an anti-up quark would have a charge of -2/3 e and -1/3. Everything is just swap signs. The strangeness would still be 0 because it doesn't have a sign. So what combination of quark and antiquark will give a charge of -1, a baryon number of 0, this sign just stands for number, as well as a strangeness of -1? Well, it'll actually be an anti-up and down quark. How I came to that conclusion was an anti-up quark has a charge of -2/3 e, and then if you add on to that -1/3 e, that'll get you -1 e, which is what we're looking for. And also an anti-up quark has a baryon number of -1/3, and then you add that 1/3 to that, you get 0. Actually, sorry, I just realized that's incorrect, because it has a strangeness of -1, meaning that it has to have a strange quark. Sorry about that. If it has to have a strange quark, well, the other quark has to be an anti-up quark because of the charge. Because the charge of a strange quark is -1/3 e, so the charge of the other particle has to be -2/3 e in order to give you a total charge of -1. And an anti-up quark would have a charge of -2/3 e. The baryon number will also cancel out, because for an anti-up quark it'll be -1/3, and then you add 1/3 onto that and they'll give you 0. And then the strangeness would be, well, for an anti-up quark the strangeness is still 0, and you add -1 to that and it'll give you overall strangeness of -1. So that's the answer. Sorry about that. Now, the interaction responsible, straight away you can look at the exchange particle. It's a W boson, and that's the exchange particle for the weak interaction, or the weak nuclear force. Now, energy and momentum are always conserved in all types of interactions. It's asking what other 2 quantities are conserved and one that is not. The only quantities that's not always conserved in weak interactions is strangeness. It's actually always conserved in strong interactions, but not always in weak interactions. Sometimes it is, sometimes it isn't. So if this ever appears in an exam, you always want to mention strangeness as not conserved. whereas 2 quantities, and 3 actually, that are always conserved, are charge, baryon number, and lepton number. So we can write charge at 1 mark, you can write baryon number, but you could have also written lepton number for that second mark. Yeah, hopefully that makes sense. Thanks for watching.